Greetings, this is section 5.3, solving exponential equations, number 6, okay? So it says, given f of x equals 50 times 1.25 raised to the x, determine the following and show complete work. So f of 5, well that says take our function and evaluate it at 5. So that'd be 50 times 1.25 raised to the 5th power. Okay, let's go get our calculator out. And we're going to do that on the calculator. We're not going to do any of the calculations, the actual numeric part, by hand. We'll let the calculator do that for us. So it's going to be 50 parentheses 1.25 raised to the 5th power, which gets us back 152 point, let's go 59. We'll go out 2 places. So this is approximately 152, what did I say again? 0.59, yes. Okay, so that takes care of that one. That's part A. Let's take a look at part B. They want to know f of 50. Okay, so f of 50 is going to be 50 times 1.25 raised to the 50th power. Okay, so let's get our calculator out again, and let's go ahead and do that. So 50 parentheses 1.25, close the parentheses, raised to the 50th power. We get back, what is that? That's 3,503,246.616. Okay, we'll give them the whole shenanigans here. So 3,503,246.161. Alrighty then. Okay, cool. Those aren't too tough. Just plug and chug, basically. Well, C and D get a little more complicated because now they want us to find the y value, excuse me, the x value for a given y value. In other words, they're giving us f of x equals 75, and they want to know what the corresponding x value is. So what that says is that 75 is equal to 50 times 1.25 raised to the x, and we need to solve for the x there. Now in chapter 6 we're going to learn how to do that algebraically using logarithms, but in this chapter they're going to do this simply by graphical. So what that means is we're going to take and set y1 equal to 75, and we'll set y2 equal to 50 times 1.25x. And we will go find the point of intersection between the two of those. So we're going to have to do a bit of adjusting on our window here too, because it's definitely not going to work in a zoom standard. Okay, so let's get our calculator out here, move it off to the side just a wee bit, hit our y equals, and we'll put 75 into y1, and we'll put 50 times 1.25 raised to the x power into y2. Okay, once we've done that, let's just think a little bit about this. All right, so we know that y1 is a horizontal line passing through 75 on the vertical axis or the y-axis. So we know that we're going to have to go up to, say, about 100. So let's go ahead and do that. So we know that our y max is going to need to be roughly around 100. So if I'm going to see that 75, that's going to have to happen. Now, the rest of it, I don't really have any idea yet, but let's go ahead and expand out the x max a bit. Let's make that go out to 20 just for the time being. See if that helps. I'm just going to guess and check thing. Didn't even need to go out 20, did I? Because there's my point of intersection right there. So I think I'm going to come back and change my window just a smidge. We'll go back to negative 10 to 10. Turns out that would have been just fine. And let's change our y scale to 10 so we don't have that bold-faced y-axis. So once you get those window settings input, press graph. It's so pretty. Okay. So now the value of x that corresponds to our solution can be found by going second, calc, number 5 for intersection, and then the 3 questions that ask you: first curve, hit and enter; second curve, hit and enter; and third curve, guess, hit and enter, and it'll go right to the point. So it's approximately 1.817 if we go out 3 places. So x is equal to 1.8, what did I say? 817, all right? Approximately equal that, so that's not exact, right? So we'll put squiggles in there. Okay, so hopefully that makes sense how you go about doing that. So to show our complete work though, we really should put a sketch of this onto our homework paper. That is, if you come back here, that graph, we should show a sketch of that. I mean, how did I get from this point to this point? Well, I had to go and draw the graph first, right? So we'll make a reasonable sketch of this, showing our point of intersection with the x and the y, and we'll go ahead and give our endpoints, our maxes and our mins and our axes. So if somebody else wanted to reproduce the graph, they could do that. Okay, cool. All right, same song, second verse now for part D. So we get negative 25 is equal to 50 times 1.25 raised to the x. Okay, well, how should I go about solving that? All right. Well, we can do as we did before. In other words, come back over here to the y equals and notice that I put in the left-hand side and the right-hand side into y1 and y2 respectively, right? So I can put in negative 25 into y1 and 50 times 1.25 x into y2. So since I cleverly did that in the last one, all I got to do is come in and change y1 to negative 25. So I need to also go adjust my window because my y min is only at negative 10. Let's go down to negative 30 here so we can see a bit more of our negative y-axis, because we know that y1 equal to negative 25 is a horizontal line going through negative 25 on the vertical axis. Ay, hang on, time out here. Change the right numbers, Mike. Oh my lord. I tell you, some days chickens, some days feathers. Y min, not X min, Mike. You said the right thing and then changed the wrong number. There we go. Ah, muy bonitas. Okay, and so what we see is that we've got an exponential function here, which we know has as the x-axis a horizontal asymptote, so it's never going to come below that. And we got the line we're trying to intersect with below that. So there's no intersection. Which means there's no solution. And if you think about it in terms of our earlier discussion about the domain and the range of this part, which is an exponential function, we know that the range of that function goes from where? Well, it goes from 0 to positive infinity. So it's never going to get down to negative 25. There's never a value of x that you can input to this function that will cause it to be equal to negative 25. Well, hope that helps. If it doesn't, please let me know and I'll do what I can to make it better.